Let's assume y varies at a constant rate of change of m with respect to x. We will also assume that y is equal to y1 when x is equal to x1. Now graphically, if we assume x1 is there and y1 is there, then we have a reference point x1, y1. And the general linear function formula tells us that y is equal to m times x minus x1 plus y1. Now if we pick any value of x, so if we assume that x is right here, then we can decide what each part of the formula represents. So x minus x1 really represents the change in x from x1 to x. So if x changes from x1 to x, this change in x is equal to x minus x1. So we say that this part of the formula is equal to the change in x from x1 to x. Now if we multiply that change in x by m, we are computing the change in y from our reference value y1 to the new value of y. And this is because the change in y is m times as large as the change in x, and the change in x is equal to x minus x1. Now if we take that change in y, and we add it to the initial value of y, what we compute is the new value of y. This is because if we take the change in x, so if we take the change in x, and we add it to our initial value, this is the change in y. If we take the change in y, and we add it to the reference value of y, what we compute is this new value of y. Therefore, our new point is xy, and we know that y is equal to m times x minus x1 plus y1. Now let's look at another scenario. Let's again assume that y varies at a constant rate of change of m with respect to x, and this time we'll assume that y is equal to b when x is equal to 0. And this tells us that our vertical intercept is 0b. And we can use this vertical intercept as our reference point for our linear formula. Now the general linear function formula tells us that y is equal to m times x minus x1 plus y1. And our reference values for x and y, reference value for x is 0 and for y is b. And therefore our formula simplifies to y is equal to m times x plus b. Now in this scenario, if we pick any value of x, then we can imagine x increasing from 0 to x. So this change in x is really just equal to x. You can think of this as x minus 0, but that's still equal to x. So in this formula, the x can also be thought of as the change in x from 0 to x. Now once again, our change in y is m times as large as our change in x. So this change in y is equal to m times x. And therefore, this m times x part of our formula really represents the change in y from our reference value of y, which is b, to the new value of y. And when we take that change in y and we add it to our initial value of y, we get the new value of y. Now, this form of a linear function, y is equal to mx plus b, is sometimes referred to as the slope-intercept form. So slope-intercept form. And this is really just a special case of the general linear function formula. So this is really a special case when our reference point is 0b, or our vertical intercept. And we call it slope-intercept form because we have the slope, or the constant rate of change, and we know the vertical intercept. So in scenarios when we know a constant rate of change and we know the vertical intercept, we can simplify the general linear function formula to this form: y is equal to m times x plus b. Now let's look at one more scenario. Let's assume y varies at a constant rate of m with respect to x, and now we'll assume that y is equal to 0 when x is equal to 0, which tells us we can use the reference point 0, 0. And again, the general linear function formula tells us that y is equal to m times x minus x1 plus y1. And our reference value for x is 0, and our reference value for y is 0. So our formula simplifies to y is equal to m times x. Now in this scenario, x again can be thought of as the change in x from 0 to x. So our change in x from 0 to x is just equal to x. And again, if we multiply that change in x by m, we compute the change in y from our reference value of y, which is 0, to the new value of y. So this change in y is equal to m times delta x, and delta x is just equal to x. Now our reference value of y is 0, so the new value of y is equal to the change in y. So the change in y and the new value of y are equal. And therefore, y is just equal to the change in y, which is equal to m times x. Now this formula should look familiar. This formula tells us that y is always m times as large as x. And therefore, y is actually proportional to x. So in this case, we have proportionality between x and y. And therefore, proportionality is just a special case of the general linear function formula. And this occurs when our reference point is 0, 0. So anytime we have a constant rate of change relationship and our reference point is 0, 0, our two quantities end up being proportional.